Okay, let's try this table, okay? We know degree of freedom is minimum of what? Nx minus 1 and ny minus 1. Nx is 21, ny is 23. Both minus 1 become 20 and 22. Smaller of the two is 20. And we know from the previous calculation, we know the calculated p-value is 2.31. So this is our p-value, the upper tail. The red upper tail is 2.31. But let's see, how can we use t-table? Okay. 20 degree of freedom, move horizontally. You find 2.31 is bounded by 2.086 and 2.528. 2.31 is between these two numbers. So move this up. The right tail of this one is 2.5%. The right tail to this one is 1%. So the p-value is bounded by 2.5% and what? And 1%. Let's look at this graph. Okay? Let's look at the graph. Probability T 20 degree of freedom greater or equal to 2.31. 2.31 is here. In the table I just showed you, it's bounded by 2.086 and 2.528. Now in the table, the right tail, when this critical value is what? 2.086, the corresponding upper tail is 2.5%. And for the number on the table 2.528, the corresponding upper tail is 1%. And this is p-value. So we know p-value is between what? 2.5% and what? 1%. So we say probability T20 greater or equal to 2.31, which is the red upper tail, is bounded by this one. Probability T20 greater or equal to 2.086, and from the table we find this is 2.5%, or you say 0.025, okay? 2.5%. And on this side, 2.086 is what? 2.5%. On this side, 2.528. 2.528, the corresponding upper tail is 1%. So this one is what? This one is 1%. Okay, let me try one more time. 2.31 is a calculated p-value, and the upper tail, the corresponding upper tail, is p-value. In the table, we find 2.086 and 2.528. Bound the number we try to find, 2.31. This is a lower bound, this is upper bound. Let's look at upper bound first. 2.528 and what? Even bigger. In the table, it shows what? It's 1%. Okay? It's this 1% here. And the other number, the lower bound, 2.086, or even bigger. Corresponding upper tail, you find is here, 2.5% or 0.025. So the p-value is bounded by 1% to what? 2.5%. So it's between 1% to what? 2.5%. P-value is between 1% to 2.5%, less equal to alpha equal to 5%. So step 5, when we draw the conclusion, we reject H naught since p-value less than what? Alpha equal to 5%. So our conclusion is the correct data is significant enough to reject H naught, because under H naught is true. The chance we're going to see this happen is very small, almost impossible to see. So once we see it, we will rather believe we see it, not because H naught is true, because H naught is not true. That's why we see it. So small p-value lead to the rejection of what? H naught. Okay?